So let us solve this question. Which of the following functions would have only odd powers of x in its Taylor series expansion about the point x equal to 0? So basically, if you see about t is equal to 0, for example, if you take t is equal to 0, the Taylor series expansion of the Taylor series expansions are sin t is equal to t minus t cube by 3 factorial plus t power 5 by 5 factorial minus t power 7 by 7 factorial plus and so on infinity, and cos t is equal to 1 minus t square by 2 factorial plus t power 4 by 4 factorial minus t power 6 by 6 factorial and so on infinity. So these are the normal Taylor series expansions that we generate during our Taylor series analysis. Now if you see the first function, what is the first function they have given you? Sin x cube and sin x square. So first is sin x cube. So when you write sin x cube, so if you put t equal to x cube in this equation, we have x cube minus x cube whole cube x power 9 by 3 factorial plus x power x cube whole power 5 15 by 5 factorial minus x power 3 into 7 21 by 7 factorial and so on infinity. And second we got sin x square, correct? So sin x square is equal to, again if you put t equal to x square here, x square minus x square whole cube x power 6 by 3 factorial plus x square whole power 5 x power 10 by 5 factorial minus x power x square whole power 7, so 14 by 7 factorial and so on. This sequence goes, this series go on. Okay, then what about the third option? Cos x cube, fine. So cos x cube is equal to, so if you put t equal to x cube here, 1 minus x power 6 by 2 factorial plus x cube whole power 4 x power 12 by 4 factorial minus 6 x cube whole power 6 x power 18 by 6 factorial plus and so on infinity. And what about the fourth term? Cos x square, I guess, correct? Cos x square, fine. So if this is cos x square, then 1 minus x square whole square, so x power 4 by 2 factorial plus x power x square whole power 4 x power 8 by 4 factorial minus x power 12 by 8 factorial and so on, sorry 6 factorial, I'm sorry. So this is 6 factorial and so on infinity. So these are the Taylor series expansions. Now they are asking which would have only odd powers of x. So out of these 4 expressions, which have, out of these 4 series, which series has only odd powers? This sin x cube, correct? So out of these 4 expansions, only this is the expansion which has only odd powers of x. Remaining all have only even powers, okay? But this guy has only odd powers of x. So therefore sin x cube, this is the function which has only odd powers of x in its Taylor series expansion about x is equal to 0. You may have a doubt, when t is 0, how these things are 0? Because if you put x cube equal to 0, that means x equal to 0 in all these options. Similarly, when x square is equal to 0, x equal to 0. So the same Taylor series expansion could hold good for all these things. Thank you.